Right, this is the Red Bull Creations start of the creative process. Okay, what project are we doing again?
We don't know yet.
We don't know, we're just brainstorming.
Okay, what's the brainstorm? Oh, perfect. We can't see your face.
This is a team.
Yeah, Darren's running late.
Past inventions or objects from the past?
Well, what does past mean, like a year ago?
Technically, yeah.
I think so.
I just reinvented the Twitter. What I'm thinking is you put a motor at the top here that has a mirror glued to it, and have your laser hit the mirror, and then the mirror spins. So you have a plane that way, right? Like, and it's not so hard to line up, right? You could see the laser beam, and it's big, and you just line that up,
right?
And then secondly, to detect that laser beam shouldn't be difficult. That should be the easiest thing in the world. And the Arduino should be doing millions of instructions per second. So if you're going 1,000 RPM on a motor, it should be very easy to turn the photodiode on and off these two angles that there's an object blocking it.
Right.
But not only that, you know that object lies along this line.
The object being a stream of piss.
A stream of piss, yes.
Right. Okay.
So wherever it is, and when you time it out with the speed of the microprocessor, you should have fractions of an inch, like a tiny fraction of an inch precision on that. And you write your name and it's like, message for the guy behind you. But everything. Did you see that?
We're running low on Red Bull though, Jeff. Did you? So now you are officially done the assembly of your Arduino SB microcontroller. Now download the latest Arduino software from the Arduino. Alright, the moment of truth to see if we did this properly. We should get a power light. Alright, what phase are we in here? Phase 3?
Phase. Well, we've Arduino done. Software running on it, test it works, done. Test some input, test some output, done. Photo transistor, that's...
Alright, our latest phase. Got the Arduino, or go walk us through here, Jeff.
Alright, so we have the laser beam bouncing off the mirror, coming down to our detector. We put it into a pen. Dan's brilliant idea, on a magnet, so we have perfect swivel control. And then we can manually adjust the pen and the magnet so that, as you probably, I don't know if you can see the numbers, but the numbers go high every time it passes. It is scanning the laser along our detector. You can kind of see anywhere along the way how much that tinfoil inside really repeats the beam, so that the detector at the end can always detect it. Line that up. And it runs like so. So anywhere, even though this looks like a solid field, it's a rotating beam, and if we interrupt it, you can use the microprocessor to tell exactly what time it was interrupted, so you know where the beam is, and then you know where the P is.
Don't pee, please.
Update so far where we're at is we still need a little bit more work on the detector. We think it's pretty good, but at this point we're ready to put it into a urinal, if we had a urinal.
Makeshift urinal.
So we're going to put it into a makeshift. This is going to be our urinal. Maybe it's behind your telescope.
Maybe. Salvaged.
Or your robot router. Or your airplane. Or, what is that, a sword?
No problem.
Right, so now we have on video our new sensor array with the glass rod. Glass rod cut by drill bit. Okay, finally the project, so I'll show you what we have here. Their laser urinal. So this is our prototype system. There's actually two simple parts here. You have a motor with a spinning mirror. Laser will hit that, spin the beam around, and a sensor at the bottom to detect that and interruptions in it, so you can locate based on the interruptions where objects are. For example, track a flying stream of urine real time. So you can use it to say, for example, write your name in the urinal instead of writing your name in the snow. Put a monitor at the top so you can see what's happening, tweet the information somewhere, whatever. And it's better than graffiti, right? Now the parts here, this motor, or salvaged one with a makeup mirror glued on, could obviously replace with a tiny little one like inside a laser printer. You can make a self-contained module that puts up on the top of your urinal. You'd never see it. The glass at the bottom, replaced with an acrylic one. You don't need the tinfoil around it when you have a proper photo detector. Acrylic plastic rod, anything, no electronics in that, just photo. So easy to put anywhere like say in a urinal. And obviously we have a rat's nest going on here, but a little bit of simple circuitry to put somewhere. Simpler than what you'd find in common everyday gadgets all the time. So a quick introduction to what's happening. We have a photodiode, comes into operational amplifier. We had to amplify the heck out of it and play with that, and that's the problem because we don't have a proper photodiode. You can't buy one in town. Just have an LED turned backwards, but that signal is then fed into the logic circuitry. So that has to decide what's happening when, based on where the beam is and so on, to start the count, stop the count. You can take 2 counts when the beam is interrupted and how long that interruption is. So we have a 10 megahertz crystal oscillator, binary counting chips, and then those counting chips interface with the Arduino, so it has to request a hold in the count. If the count isn't done, the count continues, and so on, so that interaction happens there. Now, I'll show you in practice here, a laser beam. You can see when that hits our glass rod here, it lights up the whole rod, so that's a nice clear signal, should be easy to detect. If you have a proper photodiode, easier. So turn that across the beam, just touch it, and that LED at the end there indicates that we're sensing it. And it's actually, quite fast. No real problems, except the amount of circuitry we had to put in there, you get a lot of noise out of it, and that's where the problem is to filter that out. So when I do this, turn on our serial monitor, and I can beam back and forth. You get a lot of signals, in microsecond range, and we can time things out quite perfectly on that. So that all works quite fine. Problem is when we go like this, it gets a little bit trickier. So this is how the system will work. Stick your beam in there, then you get a nice laser line, line it up with your sensor. You might want this to be infrared so people don't see it like a laser mouse, but that lines up perfectly. We still get detection out of it, but the problem is that it's turning on and off many thousands of times, more than it should. So you tune it all perfectly well and you put some filters in there, capacitors. It's very hard to tune when you have a big loop of resistors. I haven't touched that. We get signals out of it, so it's hard to tune with the circuits that we have. We need to order some proper parts to make it work properly, but we get to tune a little bit. We can get XY information out of this, and that is pretty cool.